This podcast is brought to you by the Environment Institute of the University of Adelaide. For further information, visit our website at www.adelaide.edu.au/environment.
The work that I'm doing through planning, the Department of Planning and Local Government, as it's called now, and the research that my partner and myself are doing at Fifth Creek Studio, sort of look at the public realm and say, we can't keep doing what we're doing because the climatic changes are happening. They're happening so quickly. We've got to start planning for the next 10 years, and by the time we actually get to build it, it'll be out of date anyway because things have changed. But you've got to start looking in during those perspectives. And I'll be looking at work, just some of the natural systems, not all of them. I'll be just really briefly talking about some of the things we're doing, especially at planning, which is quite interesting work, and how we can build up the density in the city and maintain our open space. First of all, as a city is an ecosystem, and I'm not a scientist, so I have a very simple definition. As an ecosystem is a community of living things interacting with non-living things. I understand that, and I think that's a really simple thing. These systems are considered to be open systems, as both energy and matter are transferred in and out, with the resulting change and evolution over time. That last phrase, resulting change and evolution over time, is really important nowadays, as our ecosystems and our weather patterns are changing. We've got to... Normally this has happened over a long period of time. Now it's speeding up, and we have to get in and actually work with that quickly. So that's one premise. I work on two premises. A city is an ecosystem. The other one is a city is a water catchment storage area. What I'm saying is, if you look at the natural system, you get about 20% runoff of water, or 20% base load of water from the ground, 27% off runoff, which is like Kangaroo Dam, so you get about 40% of the rain being caught in that dam. That's if they're not topping it up from the River Murray. But in a built environment, when you look at the city, your base flow is only 5% because there's no infiltration, very little. But your surface runoff's 58%. And when you put those figures together, the city makes a lot of more sense. You've got 63% catchment compared to 47%. So if we're using those hard surfaces, water runs off. You don't lose it. But the trick is how do we store the water within the city so we can reuse it? So there are things like roofs, vertical walls, storing the water in the road pavement and things like that, so we can recover that. So they're the two bases that I'm working on. So this sort of falls into what I call green infrastructure, and it's a common term happening around the world now. And green infrastructure, and I'm introducing this to government, which is another interesting process in itself. But what green infrastructure, as I see, is we're using the natural systems in the urban environment. We're using these natural systems to replace their existing infrastructure, such as here's an example of looking at water. Our cities can't replace the infrastructure. It's too expensive, so we need to find ways of actually doing that naturally and at the same time in enhancing the built environment around us. So we can augment this, and this can be a great cost benefit to the state or to the city. The rainfall in Adelaide is going to be quite different to the way it is. We're starting to get the effects. We're going to have about the same amount of rainfall, give or take whatever scientists you believe. But the way the rain's coming is going to be in bigger, in intense lots. So in the top diagram, you'll see the purple water is the rainfall and the runoff we normally get on our paved areas. What's going to happen? We're going to get that rainfall in bigger loads. So the blue on top becomes the water volume. So those pavements are catching a lot more water. If we don't improve the infrastructure to take that water away, we'll have this nuisance flooding. So there's some real issues in the built environment. What happens? Things like Rundle Mall will get a lot more water on its surface. The infrastructure there won't cope. So we'll get wet feet when we walk down there, and it might go into the shops in an extreme case. So what we're looking at is the bottom diagram where we reduce the catchment, the paving area. So with that intense rainfall, we have a smaller, more like current runoff, but we put it into the ground. We put it into biofiltration strips. We actually let the water clean through these systems and soak in. And it's more like the photographs from work that Taylor Cullity had done in Melbourne, and it's that style. We reduce the catchment, and we're working with Mount Gambier Council at the moment in their new plaza areas with this technique of actually reducing the catchment. So that's sort of looking at rain. Other things we're looking at is how you use trees. Trees are a natural system. They're a heat pump. There's a air circulation around a tree within its canopy from its transpiration. There's water, different humidity levels and air pressure. So you get a natural circulation. And this is some work being done, was in America, was for Dubai. Whether it's been built now with the financial crisis, it might be another story, where they're building giant trees, artificial trees, where you actually bring in the hot air. The hot air might be up there 40 degrees. You actually spray mist water, which then reduces the air temperature. You get a change in air pressure, and you can bring the cold air down through a downdraft chimney effect to bring a temperature back into the mid-20s at the ground. Singapore are looking at this in their new parkland developments on their waterfront, and they're looking at these artificial trees that are 7 stories high. Taking that sort of, and Jen, that's a really old technique. If you remember back, people of my vintage, of the old Parliament House in Canberra, there was the Senate and the House of Representatives courtyards. They had major trees in the middle, and they were designed, those trees, to pump out the hot air. And if you look at the Treasury building, it did have big scale trees to do it. It's a very old technique. Taking that principle, we can look at places like Rundle Mall and outside malls. They're going to become really less populated as the temperatures rise, as people worry about skin cancer. People are going to move to the internal malls, which have other social problems because they're private land and they can exclude different population groups or whatever. And because they're going to be air conditioned and comfortable. But if you look at the mall, take that shade structure there, I quickly just did in principle what you could do. You can collect the water on the roof, take it down, store it under the paving there, put solar panels, stick onto the glass. That will pump the water back up, mist it out, and then you start to get your air temperature changes and use the downdraft chimney effect to bring cold air and air condition these malls. Therefore, if you had a series of these, the actual temperature would be reduced, you could attract people back, and there's an economic advantage then back to those businesses. So we've got to look at how we handle the public realm, and it's going to be quite different to how we're doing it now. And if you take these natural systems and you actually integrate these natural systems, and they will then start integrating with each other, you can actually treat pollutants and stormwater runoffs and so on. And this is a very quick conceptual sketch of a project where we're working with at the University of South Australia. We've just got some grant monies to start the preliminary design work where we're looking at treating water, storing it under the road pavement within the airspace of the gravels, using the trees for street trees for shade effect, reducing the heat island effect off the pavement, using cool pavements, and then recirculating that water back into the buildings, into their new buildings as reuse water. We also start looking at using green walls and green roofs. So that, again, green roofs are extremely important for storm water retention and so on, and the green walls are very similar, but we can use those green walls to cool the sun on the walls surrounding this laneway. So and that brings me to where my interests are even more developed, is looking at green roofs and walls. Green roofs, you can use them as urban forms. You can do any shape you like, how you do, anything nowadays, because the technology's there. And these dome roofs are the Californian Academy of Science, where they've actually used the actual topography to cool air and bring that down into the building to air condition the building. So there's lots of benefits. We can increase shade and insulation, reduce energy costs, and in multi-storey buildings we only have to reduce the amount of energy by a minute amount to get major cost savings. As Stefan said, the tower is the sides are exposed, but on a tower like the Chicago Town Hall, you just shade the top, and that has an effect for only the first few floors. So to me, then, we really need to look at the walls and have greater benefits. But just looking at natural systems, we can use on the rooftops, we can use the natural system of natural cooling by plants to cool the ambient temperature around photovoltaic cells. They can actually work up to 20% more efficient than on a conventional roof. This was a 5-year study by German scientists who have sort of done this work. And if we were able to say, well, we can get 20% efficiency in a new photovoltaic cell, commercial world would take that up and say this is a great benefit. We can do this with a green roof, and we have lots of other benefits. We can actually put constructed wetlands up on the roofs, and this example here is a John Deere factory in Germany, where they actually take the water out of the production line, take it up on the roof, cool it, treat it, and then reuse it back into the production line. So the technology's there. We can actually have a lot of our wetlands up on top of building roofs instead of taking up a lot of ground space, which can be used for other functions. And in a compact city, as we talk, ground space is critical. So if we can use the building fabric to do the same jobs, then that's what we're doing. If we look at living walls, they give us urban texture to the streetscape and the form. But I think they have a big benefit to the energy use of the building, because if it's a multi-storey building, you've got a lot more surface area you can treat. Technically, it's a bit more difficult. It's not impossible, and the new systems being developed, the cost is coming down. But again, they've got similar benefits, reducing the heat island effect, and so on. But if you look at the living walls, the natural systems, you can actually look at a multi-storey building, and that's a section here on the right, where you can actually use the living wall as a biofiltration. You can take the grey water out of that floor, run it through the system and then bring reuse clean water back into the next floor and so on. So you get this cascade effect happening right down the building. This technology is available. We can do it now. And on the left is a wall, a vertical wall with fish at the bottom, a fish pond at the bottom. This is in Toronto, in the Canadian Life Insurance Company, where the water from the fish pond area is recirculated up to the top of the living wall. It's then cascades down through the living wall. The fertilisers or the nutrients come out of the water. The plants use that as their fertiliser. The water comes back down to the fish pond as it's clean, and it's just a constant cycle going on. So we can actually look at these principles, these ecological principles, to look at our building facades, and we can do this if we really want to. If we put those two together, we get this ground roof connection, and this is where I see a great opportunity for Adelaide. This building's in Fukuoka in Japan. It's quite a famous building, step there. But if we had building envelopes and control around the squares, our city squares, with buildings that step back with greenery, those city squares would be 4 to 6 times more biomass there, and the cooling effect of that would have an enormous effect on the city itself. And we've got 4 major squares and so on. So there's really interesting urban forms to look at in here. If we look at these living walls and roofs and green roofs and say they're bush tops, they're ecological habitats, and then say, well, they're the habitats of what was originally here, and this is what I call a bush top. It's basically looking at what was here in the CBD before we converted it. And we put that on our walls and on our roofs. We can actually start getting a mosaic of a pattern running through the city. The city had migration patterns for insects and birds through it before we built it. So my work is to look at them and to actually set up these stepping stone corridors so we can get those migration patterns happening again. And I'm using a metapopulation theory developed by Paul Ehrlich back in the 70s. This has been developed in California at the moment. It's the only other place in the world where I know we're working on the same sort of principle, where you don't have to have a corridor that's constantly connected, as long as the distance between the roofs or the habitats are within the migration or flying distance or whatever of your targeted species, then they will move along and colonise these areas. So we're looking at the CBD, there's various routes we're looking at the moment. This is probably quite important that we're looking at increasing the open space while we increase density, and as this is about the compact city, the top diagram says that's what it was, how much biomass was there before we developed. We do the general housing sprawl, you get about 25% of biomass left. But if you tilted up that backyard, you actually create more space. You can then put another building on, or another 2 or whatever. So you can increase the density, but at the bottom's diagram shows a 3 to 4-fold density increase. We get 25% more biomass open space than we started with pre-development. And it's just a simple calculation of surface area. If we use roofs and walls, we can get an enormous amount of biospace. The only downside is we don't have a lot of deep-rooted zones. But if we do careful design, we can do that. Again, just looking at the suburban area, the top photo, the left is a typical house, and you can see on the side of the house there's a hedge. That hedge is incredibly important for habitat, for the small birds, because what we produce in the suburbs is an open woodland which attracts very aggressive birds that drive out the small birds that like the little insects. They harbour in that hedge. When we redevelop, we put 2 houses on the site where there was 1. That hedge is the first thing to go. So that habitat disappears. And what we're saying is this green wall, living wall technology could be put on the house or on the fence to recreate that habitat. We can increase that density when we can maintain the urban habitat. And that's a really important factor. And we take that one step further. We look at really dense, more like Todd-type developments where we can put green roofs on living walls, green balconies, parklands within the city. We form this three-dimensional open space system. And this is really what I'm working towards in the Department of Planning, is to get this three-dimensional open space system, because we're used to a two-dimensional everything on the ground, but to get density and to get more open space, that's what we're up to. And so on. Buildings should be more. This is a Kanyang building, as people would recognise. But we need to integrate the public streetscape with the building facade and the building and the rooftop and put it all together. And we're looking at things like the heat island effect and the heat cooling effect of the city. And we started a research program that we can actually get enough information together in the next 12 months to 2 years to actually start building envelopes where we can target putting green onto the building in strategic places to actually absorb the heat or cool the area. And there's a secondary one, is the carbon dioxide dome that's sitting over the cities. We can reduce that by the vegetation. And through planning we've got this, and this is the last slide, so I'll finish shortly. This is a program we're developing out of planning, is to reclaim the rooftops. The rooftop is a wasted space in most cities. And when you think about it commercially, there's a big area of rentable space for the building owner. It doesn't even consider it. But we're looking at it and we've broken it down into 4 elements. The environmental element, to look at adapting to climate change, our bush tops, our habitat process. The lifestyle residential rooftops, which in buildings we've got a lot more green space within the living areas of residential complexes. The business case area, or the commercial rooftop, where we can have deck chair theatres. We can have child minding centres on top of car parks with green roof playgrounds where people can drive, if they've got to drive to the city, they drive to City Park and drop off their child there, and even come back at lunchtime if they really wanted to, and then come back and pick up their child and go off. And the 4th is what Stefan was talking about right at the end, and I agree with him, is the food production. If we can grow plants on a roof or a wall, they can be edible plants. So we can have production on roofs, walls and so on. And this reduces the food miles, but there's a commercial element to complement the actual in environmental issues, and these are the things we're looking about in planning. Thank you.